Wow, that was quite a tough pill to swallow, wasn't it? No problem, though. Let's do another example to see that it's actually much quicker in practice. So let's solve x prime equals ax and draw the phase portrait where A is the matrix 1, 5, minus 2, 3. And for this, as usual, let's find the eigenvalues. So let's do A minus lambda I, the determinant of A minus lambda I. So 1 minus lambda, 5 minus 2, 3 minus lambda. Let's expand this out. So 1 minus lambda times 3 minus lambda minus 5 times minus 2. And that becomes 3 minus lambda minus 3 lambda plus lambda squared plus 10. And that becomes lambda squared minus 4 lambda plus 13. Again, you could use the quadratic formula or slightly easier, complete the square. So this is the beginning of lambda minus 2 squared. To correct it, subtract 4 from this, and plus 13. So lambda minus 2 squared plus 9. You set this equal to 0. So lambda minus 2 squared is minus 9. So lambda minus 2 is plus minus square root of minus 9. So plus minus 3i. So lambda is 2 plus minus 3i. So what makes this new compared to the last example is now we have a non-zero real part, but pretty much same as before. Pick your favorite eigenvalue. Lambda is 2 plus 3i, for example, or lambda is 2 minus 3i, doesn't matter. And then do the null space. So a minus 2 plus 3i, I. So 1 minus 2 plus 3i, and then 5, and then minus 2, 3 minus 2 plus 3i, and then 0, 0. Let's simplify this a little bit. So that equals, so minus 1, minus 3i, 5, 0, and then minus 2, 1 minus 3i, 0. And remember the trick? So you pick your favorite row, again, doesn't matter which one, and make the other row 0. So just for personal preference, I picked the second row, but you might like the first row more, doesn't matter. And let's make the other one 0. So this gives you minus 2, 1 minus 3i, 0, and then 0, 0, 0. Again, nothing wrong if you pick the other row. And so this gives you minus 2x plus 1 minus 3iy. Y equals 0. And again, here you can play the guessing game. So x equals 1 minus 3i. And y equals 2 works. Because again, minus 2 times 1 minus 3i. And then plus 1 minus 3i times 2 equals 0. And so this tells you that for lambda, equals 2 plus 3i, a corresponding eigenvector would be 1 minus 3i and 2. And again, I do want to mention there are multiple different answers that are all correct. So if you got a different answer from your colleague or your classmate, it's okay. There are many different answers here that work. Okay, and now let's build our solution. So let's build our snowplow. So remember e to the eigenvalue t. So plus 3it times eigenvector. So 1 minus 3i and 2. And again, we want to split into real and imaginary parts. So this is e to the 2t, e to the 3ti, and then 1, 2, and then plus I, minus 3, 0. And again, you full everything out. But before that, use Euler's formula. So cosine 3t plus I sine of 3t times 1, 2 plus I minus 3, 0. Now, once again, you're all invited to the foiling party. So this gives you e to the 3t, sorry, or e to the 2t. Now, so the cross terms, or more like the dot product terms, cosine 3t, 1, 2, and then minus sine of 3t times minus 3, 0. And again, I want to remind you, this minus comes from I squared. So I squared is minus 1. And then plus I e to the 2t. Now times the cross terms. So cosine 3t. And then minus 3, 0 plus sine of 3t. 1, 2. So once again, the first term is like a dot product, but with a minus. The second term is just the cross terms. And then I want to refer you to the previous video for details, but now we have two solutions that are the basis of our solution space, and then you just take linear combinations. So it's not that you replace I with C2, but that you really extract a basis and take linear combos. So the solution would be C1 e to the 2t cosine 3t 1, 2 minus sine of 3t minus 3, 0, and then plus C2 times that. C2 e to the 2t cosine 3t minus 3, 0 plus sine of 3t. 1, 2. And that's all she wrote, except for the face portrait. So step 4. Face portrait. So there's something really interesting happening here, because cosine 3t, sine 3t, that indicates something circular. In fact, last time we've seen, or in the last video, we've seen the solutions were ellipses. But here, this e to the 2t blows up to infinity. This e to the 2t, it actually goes to infinity as t goes to infinity. So essentially, the solutions, they circle around, but actually get bigger and bigger. And what this really is, it's a spiral. So solutions spiral outwards. And I will draw the spirals in a second, but in order to do that, we first have to determine which direction they spiral. So we need to do the orientation business. Which I like to remind you, pick your favorite point, let's say 1, 0, and calculate the derivative at that point. So x prime of 0 is a times x 0, and that becomes 1 minus 2, 5, 3, times 1, 0, which you can calculate, but it's really just the first column, 1 minus 2, meaning that at 1, 0, the solution goes 1 right and then 2 down. Maybe like that. 1 minus 2. And this should hopefully help you figure out the orientation of the solution. And so it turns out, because of this, the solutions, they go clockwise to infinity. So now we can draw the spirals. So it turns out it goes like that. Again, they spiral outwards because of the e to the t term, but also the spiral clockwise because of this orientation business. Those are the solutions. And how pretty. They're like little snails, like Fibonacci spirals. Maybe one more. Whee! And once again, you are responsible for the orientation, but not for the axes. The axes are a little bit harder to determine. And last but not least, I do want to mention, here we did e to the 3t or e to the 2t times the solution. If we had e to the minus 2t, then solutions would all go to 0. So it would be like this, but in sort of the reverse direction.